Good morning students. This is Digital Communication System Unit 5 Error Control Coding Technique. Here the linear block codes. Here the principles of block coding for the block of k message bits, that is n minus k parity bit or check bits are added. Hence the total bits at the output of channel encoder are n. Such codes are called n, k block codes. Here the types of linear block codes, that is a systematic codes and linear code. Here the message block input, that is moved to the channel encoder. Finally we get the output as code block output. So message bit we can say k bits. Here the message is the k, then check bits we can say n minus k. Finally we combine, means final bit is n bits. This is the functional block diagram of the block coder. Then matrix description of the linear block codes. The code vector can be represented as x equal to mg, that is equation 1. Here x is equal to code vector of x of n, and that is size of n bits. Then m is the message vector of 1 cross k size or k bits, and g is the generator matrix of k cross n size. The equation 1 represents matrix form x equal to m cross g. G is the generator matrix. The generator matrix depends upon the linear block codes used as generally it is represented as a G equal to ik p k cross q. So ik is equal to k cross k identity matrix and p is equal to k cross q submatrix. The check vector can be obtained as c is equal to m into p, that is equation 4. So thus in the expanded form we can write above equation as C1, C2 etc. CQ, that is equation 4. C1, C2 etc. CQ then is equal to M1, M2, Mk. Then finally P parity vector is P11, P12 etc. P1Q, then P21, P22 etc. P2Q. Then finally we get Pk1, Pk2, then Pkq. Okay. By solving the above matrix equation, check vector can be obtained. That is, see here the matrix hub we can write, that is C1 equal to M1 into row wise and column wise. Okay, M1 P11 plus, here the addition is exclusive or modulo addition. Okay, so M1 P11 plus M2 P21, then M3 P31, then finally Mk Pkn. Then C2 M1 P12, M2 P22 plus M3 P32. Then C3 M1 P13, M2 P23 plus M3 P33. Likewise we have to add a general matrix, normal matrix. Okay. Here note that all the additions are modulo additions. That is an exclusive OR condition, XOR gate. Now we see one problem, that is for a systematic 6,3 linear block codes, P have some value. Find all possible code vectors. So solution, given data p equal to 101, 011, 110. Here the n equal to 6 and k equal to 3. That is n comma k. So at a time 6 comma 3. So n equal to 6 and k equal to 3. K is equal to n minus k, 6 minus 3 equal to 3. To obtain check bits equation, that is message vector equal to M1, M2, M3. That is C equal to MP. Already we know the formula, that is M1, M2, M3 of 101. That is M is the M1, M2, M3. That is a K equal to 3. That is the message bits. No, so that is C equal to MP, M1, M2, M3. So finally the P value is given. That is in the question itself given. That is 101, 011, 110. But C1 equal to M1 plus M3, C2 is equal to M2 plus M3, then C3 is equal to M1 plus M3. Which one is enabled means we come to add it. That is, if you consider C1, 101 means 0 is not present at a time M1 plus M3. If you consider C2, C1 is not enabled, M2, M3 is available, so at a time M2 plus M3. If you consider C3, C3 is not available, but M1, M2 is available. So at a time we can write it M1 plus M2. So that's all. So we have to generate the table form. To obtain the code vector, message vector, check bits and code vector, weight of the code is available. No? So already we know M1 and M2, M3, C1, C2, C3 now only we have calculated. Then so finally we conclude all the values, that is M1, M2, M3, C1, C2, C3. So first we see M1, M2, M3 we have to apply 0. So M3 message means we have to go for the 4 to 1 model. 4 plus 2 plus 1, that is 7. So if we consider 4 message bits means 8421 model we have to follow. So if we consider 0 bits, so everything is 0. Okay, so M1, M2, M3, C1, C2, we have to combinedly we can write, that is M1, M2, M3, C1, C2, C3. So how we can calculate weight of the code? Number of non-zero values, So now we consider 1 message bits. Up 1 message means 4 to 1 model, that is 0, 0, 1. C1, C2, C3 is 1, 1, 0. Okay, so already we know, right? C1, C2. So you have to combinedly we can write 0 to 0, 1 and 1, 1, 0. So number of non-zero values is 1, 1, 1. Number of non-zero value means how many number of ones is available. So nearly 3. So likewise we have to write all the values. So the minimum weight of the code is 3. Okay, so that is if we not consider, we cannot consider 0 value. So other than apart from that 0, 3 is the minimum value. Okay, thank you students.